Hi everyone, we'll be starting with the session now. Hello everyone, good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 9C. Myself Anshika Jain and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GI Scholastic LLP, it is my great pleasure to welcome you to the 4th World Conference on Information System for Business Management, ISBM 2025, Bangkok, Thailand. The 4th edition of the conference is being organized in a hybrid mode. The physical event was held day after yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom yesterday and today, that is 25th and 26th September 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. Before starting this session, in this session we have 10 presentations and each presenter will be given 10 minutes for the presentations and 2 minutes for the questions and answers. On 9 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any queries or any updates, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for the session. Dr. Randy Joy. Sir is the director of the International Accreditation Office at State University, Philippines, and serves as an editor-in-chief of the Southeast Asian Journal of Science and Technology. His specialties include artificial intelligence, cloud computing, 3D printing, and research related to COVID-19 pandemic. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Good morning, good afternoon, and good evening, everyone. So it's my honor to welcome you to this session, the Fourth World Conference on Information System for Business Management. I am Randy Ventayan. Together with me is my co-chair, Professor Sayan Chakraborty. And in this session, we'll hear presentations highlight the different fields of in technological and business papers. And with that, thank you very much, Ma'am Jain, for the introduction.
Thank you so much, sir. So I would also like to introduce you to our session chair, Dr. Sayan Chakrabarty. Sir is an assistant professor in the Department of Computer Science and Technology at JIS College of Engineering, Kalyani, West Bengal, India. He has published around 65 research papers in international journals, book chapters, and conferences. His research interests include medical image processing, nature-inspired algorithms, and machine learning-based applications. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Yeah. Hello, Anshika. Hello, everyone. It's an absolute honor to be present here as a session chair for this ISBM. I have been seeing a lot of videos and lot of snaps floating around in the social media from the ISBM conference. So I'm very excited and I wish all the best to all the presenters. And I would like to welcome our co-chair also, Dr. Randy. So let's get this session started, shall we?
Yeah, sure. Thank you so much, sir. So we'll be starting with our first presentation. First, we have Mohammad Nasser to present the paper title, A Federated Learning Framework for Secure Crop Disease Detection in Decentralized Agriculture Environments. Are you there?
Yeah, I'm here.
Yeah, you may please start with
So,
your presentation.
first share my screen.
Yeah, you can share your screen now.
So I think you are able to see my screen.
Yes, I am. You may start.
So good afternoon, all of you. So I'm going to start my presentation. My paper ID is 360, and the paper title is A Federated Learning Framework for Secure Crop Disease Detection in Decentralized Agriculture Environment. And we have three authors, Muhammad Nasser, Muhammad Abu Kausar, and Muhammad Abu Naik. So let us start with the abstract of this paper is smart farming requires fast and reliable crop disease detection. However, centralized AI models face challenges. So, to overcome these challenges in a rural area due to the poor connectivity and there is some privacy risk and heterogeneous data, so we introduce a federated learning framework. Basically, the federated learning is a distributed machine learning approach where multiple devices uh, collaboratively train a model without sharing raw data to each other. So in this, a concise similar filter ensures security by removing malicious updates, while an attention-based heat map highlight disease reasons for transparency. Experiments on plant village and real drone images, actually we use this data set, and it shows that 4.8% F1 score improvement and 9.3% lower communication cost. This framework is scalable, secure, and well suited for resource-constrained farming communities. Introduction. In the modern agriculture, it's shifting towards agriculture 5.0, driven by AI, IoT, and data-driven decision making. Convolution in neural network-based image disease detection support early intervention, but centralized AI models face challenges in rural farm due to the poor connectivity, diverse data, and many other constraints are there. So in this, the federated learning address these issues by training local models on device and sharing only model update with a central server, preserving privacy and reducing communication costs. In this work, we propose a federated CNN framework for crop disease detection. This system aggregates local model using the Fed average, implies a concise similarity filter to define against malicious updates, and integrates an attention-based heat map for interoperability. Evaluating on plant, village, and drone-based dataset demonstrate strong performance under non-IID conditions, ensuring scalability, security, and transparency for real-world smart farming. We have the review of literature. Recent advance in computer vision and the CNN-based models have achieved high accuracy in crop disease detection across crop like rice, maize, potato, and many others. However, this centralized approach faces challenges in rural settings due to the connectivity and privacy issue. Federated learning has emerged as a solution, enabling collaborative model training without sharing raw data, and has shown promising results in agriculture, including maize leaf disease prediction and many other diseases. This is the table. In this table, many authors, many researchers, they already worked on this. So just I will give you a little brief about few people they work in this. The first work done by the Tiguel ETL in 2022, they use CNN-based centralized disease detection. They use the centralized one, and like this, many people they work. And our work is in this. We use the federated learning plus robust filtering plus interoperability. So basically, this will give us a more accurate result and more robust result. Major challenges remain such as robustness under non-IRD data, security against poisoned updates, and communication efficiency. Prior work like Fed average and secure aggregation address some issue, but interoperability for format trust is often missing. Our work built on this effort by integrating cosine similarity based filter for robustness and attention based heat map for interoperable farmer friendly insight in decentralized crop disease detection. The proposed framework is basically comprised of the four component. In this, we have the local CNN training, model aggregation with Fed average, robustness filtering, and attention-based interoperability. Actually, I did not put the figure. So now this is basically this is our local CNN training, and these all are the formula. So I'm not going in the detail, just I'm showing you the formula here for the local CNN training. Then we have the model aggregative with the Fed average, and then we have the robustness filtering, and then attention based interoperability. The experimental setup is done based on the two data set. One is the plant village data set, where we have the 54,000 across 54,000 images of the 14 crop, and UAV acquired imagery, where we have around 10,000 images of the wheat and tomato crop. Implementation details. We implement this proposed framework using MobileNet V2, pre-trained on ImageNet as the base CNN model. Training is performed with the Adam optimizer. At an optimize, these hyperparameters were selected after 10 fine-tuning trials with learning rate ranging from 0.001 to 0.01, ensuring stable convergence and efficient memory utilization. The federated learning is simulated with 20 client nodes using PyTorch and the Flower framework. Each fed average round consists of 10 local epoch and a total of 50 rounds are executed. A concise similarity based filter is applied with a threshold 0.5 to mitigate Poisson updates. This is the parameter we use. The CNN backbone we use the mobile net. Optimizer we use the Atom. Learning rate is 0.001. Batch size is 32. Local epoch is around 10. Fed average round is 50. Number of client is 20. Framework used is PyTorch and the Flower. Robustness is mechanism is concise similarity filter, that is 0.5. To evaluate this, we use the accuracy, precision, recall, F1 score, communication cost, robustness test, and the statistical significance. The proposed federated learning framework was evaluated on the plant village dataset, and UAV acquired imaginary under non-IRD conditions and compared against baseline federated average and centralized CNN model. The result I will show you in the next table, shows that the proposed federated learning approach achieved an average F1 score of 92.1%, outperforming centralized CNN by 4.8% and baseline fed average by 3.2%. Importantly, the communication cost remains comparable to the baseline Fed average. This is a table where we put all our result. In this proposed federated learning framework, our accuracy is around 92.3%. The precision is 91.8%. Recall is 92.8%, and the F1 score is 92.1%. It is better among the federated average baseline and the centralized CNN model. And now this table shows the communication cost in the MB. It means how much cost taken for performing this experiment. So for the 10 node, it proposed federated learning is it takes around 8.5 MB. For the 20 is 15.2, and for the 50 is 30.5, and the Fed average is 8.5. For the 20 it is 15.2, and for the 50 nodes it is 38.7. And reduction is here, there is no reduction, and but in the 50 nodes we have a reduction of 9.3%. Discussion is the framework keep data local, ensuring compliance with the privacy regulation. Since our data is the local data, so our data is almost secure. Concise similarity filter reduce the Poisson update by almost around 85%, improving baseline.
Sorry to interrupt you, sir, but yes, you have 1 minute to conclude the presentation.
Okay, fine. Then we have the attention-based model enhanced in interoperability, build farmer trust. And limitation is around 15 to 20% increase in the local training time on resource constrained devices and periodic communication every 50 rounds. So now I will come to the conclusion. The proposed federated learning framework for secure and privacy preserving crop disease detection is decentralized one, combines local CNN training, federated average aggregation, concise similarity filter, and attention-based interoperability, achieving 4.8% F1 score improvement over centralized CNN and 3.2% over baseline federated learning, demonstrating high accuracy, scalability, and robustness under the non-IRD data and Poisson updates. Attention model enhanced farmer trust through the visual explanation. Low communication overhead makes it suitable for rural network. And future work is basically in future we will do optimize edge computing and robust processing for adverse weather and expand to other crop and diseases. And these all are the reference. Thank you for the presentation.
Thank you very much, Dr. Mohammed Nazar. Okay, Ma'am Jain, can I ask the questions now?
Yeah, please, sir.
Yes, sir.
Okay. Congratulations on your presentation. And here's my question. What do you see as the biggest challenge when deploying this framework in the real world? Maybe you can mention some hardware limitations, connectivity, as mentioned in your paper, or farmer adoption.
Definitely, sir, because in the rural areas, farmer are not much. Uh, they have the knowledge about these things, and set up these things with the in the rural area is very difficult, because sometimes we have the problem with the connectivity. Sometimes we are not able to adjust our all the framework equipment, everything. So due to this reason, we have this. These all are the challenges.
Okay, so maybe in your next study, you aim to solve those limitations. Thank you very much.
Yeah, sure, sir. Thank you, sir. Thank you.
Yeah, I have a couple of questions regarding the research paper that you have just presented. First of all, congratulations on your presentation. Uh, First of all, I'd like to ask that what was the size of the data? Because I didn't notice it throughout the presentation. Uh, is it
Uh,
mentioned?
yeah, it is mentioned. It is mentioned. If you see here, it is around 50,000. Yeah.
Yeah,
This is
50,000.
plant village. It is around 54,000 images available for 14 crops. And actually, I work for only for the two crops, wheat and tomato.
Wheat and tomato. Okay. So, are there any uh, limitations or problems or issues you have found out while pre-processing the data set?
Yeah, sometimes data is missing, and sometimes uh, due to the some size, we face some problem.
Okay. Okay. The another question is that why specifically ImageNet was chosen? Why not other similar models that are available for same purpose?
Uh, Actually, sir, I got this data set, and I plan to work with this data set only. Maybe in the future, I will work with the non-image data set.
No, no, you have mentioned ImageNet in your, I think, in the materials or methods or in the proposed methodology section. So my question was that why ImageNet? Why not other similar models? I think ImageNet was used. You have mentioned it in your one of the slides I have seen.
Yes,
So
yes,
that
sir.
was my question.
Actually, I
Okay,
tried with
anyways.
this only.
Okay, okay, no
Okay.
issues. Thank you.
Thank you so much for your presentation. We'll be moving on to the next
Thank you.
presentation now. Next, we have Makran to present the paper title Active Directory Attacks and Defense. Are you there?
Yes, Anshika, I'm here.
Yeah,
Uh,
you may please begin with your presentation.
yeah, just a second. Let me first start sharing the screen. Let me know once it is visible. Okay.
Yeah, it is visible. You may please start now.
Fantastic. So first of all, good morning, good afternoon, good evening, everyone. My name is Makran Katam, and currently I'm working as a cybersecurity consultant in a company called as Allstate. Recently, I have completed my MTech in cybersecurity, and today's research paper is around Active Directory attacks and defense, and my paper ID would be 310. So this is the outline of the presentation. So we'll deep dive into what is the background, what is the objective, and what are the key concepts and the technical details around the Active Directory, the attack mechanisms that we have, and what are the defense protections that can be implemented in order to. Hello.
हाँ जी योगेश बोल रहा हूँ सर हाँ सर
Hello.
Yeah, you may please continue.
Okay, sorry, I thought someone was having some questions around it. But yeah, so these are my presentation outline. We'll deep dive into what are the attack mechanisms that attackers are using at this point in time from the black hat point of view, and what are the mitigations or the remediations that we can put in place in order to, reduce the attack surface that can be there from the blue team point of view. So Introduction is pretty straightforward. Active Directory is something that we all use in the IT organizations, wherein it is considered as a core component and it acts as a backbone of identity and access management. Okay, so it works as a centralized authentication and authorization for all the users, for all the assets that we are managing in the organization, right? So, for example, if I'm a new employee who's joining in an organization, right? So first of all, my ID will be created in that particular Active Directory, and then only I will be able to access the resources that are available within that particular organization. So there are multiple terms such as, role-based access, privileged identity management, all that will be fallen under identity and access management. But as a core component, our Active Directory is something that is very useful, or I would say it is very much famous, which the organizations use in order to facilitate the identity and access management. As I mentioned, cyber criminals are leveraging various techniques in order to exploit the Active Directories through the use of active vulnerabilities. There could be a lack of hardening that could be possible. There could be privilege escalation. It could be vertical. It could be a lateral escalation that could be possible. There could be credentials theft as well that could be possible on these Active Directories. So in this particular discussion, we will explore various techniques that are being used by the Active Directories and what are the defense mechanisms that we can put in forth to mitigate this particular attack. Understanding both offensive and defensive tactics, it is useful for creating the resilient security posture, and it can help us to basically reduce the, I would say, the impact of the attacks or the potential monetary impacts to the organization. So that's the idea why I selected this particular topic as my research paper. This particular research paper is focusing, how to defend on the AD attacks. It includes, since it mentions about mitigation, it also includes what are the security best practices that we can use in order to configure the AD securely, and how we can also monitor the suspicious activities and respond to incidents effectively. With that, I would like to emphasize on something called as local security authorities subsystem services. Okay, so this is a very core process memory within the AD, as it provides the access for the lateral movement within the network. LSASS credential dumping has become somewhat prevalent in the recent future, I would say. In the recent past, the cyber criminals are,
We just want to make a point that are you still on the introduction or are you moving slides?
I'm moving slides.
But it's not getting, yeah, now it is.
Okay, yeah. So
You're still on introduction.
yes, I'm still completing my introduction before I move on to the literature review
Yeah,
and
great.
stuff like that. Yeah. So as a part of the introduction, I wanted to make sure that we understand what exactly this paper is all about. So as I mentioned, LSAS is a process memory. Also, there are some group managed service accounts which are also being stored as a part of the AD management, so that hackers are basically trying to target these items in order to basically get hold of the clean text passwords that the organization could be possibly using. Literature review. I have reviewed several study material, as you can see on screen. I'm not going to name one by one, but these are some of the uh, research papers that I have gone into to understand what could be the way forward and how it can be benefited from my research study. Moving on. I'll just skip on the background because I already covered it in the introduction part. About the objective, we would like to understand how the AD architecture works. What are the comprehensive defensive solutions that are in place, and what are the defensive strategies that we can put forward. Okay. Again, I'll just skip on this particular key concept part because I've already covered it. As a part of the Active Directory, right, we create something called as forest and organization units. It acts as a controllers in global catalogs. So AD operations such as group policy management replication, it acts as a very core component of the enterprise security as far as the Active Directory is concerned. As of now, as we can understand, access control, who are the people who are accessing the Active Directory, how the role-based access is happening for the administration, and if there is a multi-factor authentication is in place, is something that is very vital when we try to understand from the Active Directory point of view. Now, coming to the point that how attackers are leveraging the Active Directory exploits or Active Directory vulnerabilities, basically they're trying to they're trying to launch an attack in order to breach the Active Directory and the operating system. Is basically they are trying to target the LSASS process memory, as I mentioned in the previous slide, because it holds the core lateral movement kind of data within that particular process. And if that is breached, then attackers can be able to move laterally and vertically as well within the environment. Microsoft had participated in evaluation of the independent testing organization. And basically, it was specifically on detecting the LSASS credential dumping techniques. The test, which evaluates the several endpoint platforms and endpoint detection response, EDR vendors, basically CrowdStrike for that matter, is the first time AV comparators focused on a single attack techniques. And we are happy to report that, as per them, it was reported that Defender, which is basically a Microsoft solution that has passed all the 15 test cases used by the dump user voice credentials. Okay, so that is some kind of a research that was coming from the Microsoft point of view.
Sorry to interrupt you, but you have 1 minute to conclude your presentation.
Okay, so I will maybe I'll just quickly move on to the defense mechanisms. Maybe under the defense mechanisms, we can see that GPO hardening is something that can be used in order to defense the AD systems, such as Samba 1 or NTLM versions. It can be hardened in order to reduce the attack surface. We can also implement something called as multi-factor authentication and the credential protection tool such as LSASS memory protection and Windows Defender credentials. Okay, so these are some of the defense measures that we can put in forth. So this is kind of a framework that we are suggesting in order to make sure that attacks are getting limited and attacks are getting mitigated on the fly itself. So to conclude the presentation, as you can see on the screen, we have taken up a bunch of results which are basically a comparison of a pre-defense environment and a post-defense implementation. So average time to detect the domain admins, earlier it was 45 minutes, but after the hardening, after the patching, after the multiple security measures that are taken place, so it was either blocked completely or it was over 5 hours. Successful credential harvesting through LSASS, it was 87%, but after that it was reduced to 14%. Detection time, it was more than 24%, but with the help of SIM and monitoring, it was less than 10%. Lateral movement plots, it was 6+ per user, but it was reduced to 0 to 1 after the hardening has been performed. And false positive rate, it was earlier quite high, I would say, but after the post-defense implementation, it was reduced to medium and low. So that was the whole presentation that I had. So as I conclude this, due to the time limitation, I welcome any questions or thoughts you may have, and please share your insights or seek clarification to any points that I discussed. Thank you.
Thank you so much for your presentation. So, do you have any questions?
Okay, thank you very much for that wonderful presentation. By the way, this is just a practical question to
Yeah.
you. How do you see AD security evolving in the next 5 years as attackers become more sophisticated?
Now, with the use of AI, I would say the Microsoft has recently released something called as Entra ID. So, securing Entra ID, securing Active Directory, I think it is going to be crucial. And the importance of privilege identity management, monitoring, and identifying and detecting the suspicious events. I think that is going to be a key focus going forward, especially with the use of AI, I would say, because cyber criminals are actively using AI tools to, to launch an attack on our organization.
Okay, thank you for that insights.
Thank you. Yeah.
Yeah,
Any other questions?
Makarand, yeah, I have a question. Can you go back to your results slide? I have one query regarding that.
Sure.
Yeah, the false positive rate, it is mentioned as unconfigured, right? And after post-defense implementation, sorry, after defense implementation, it says that medium to low with tuning. Does it mean that the tuning happened with the configuration, or what is the meaning of this tuning? What did you tune in the defense
So
implementation?
tuning is basically, I would say it is more related to the hardening of the GPU of Active Directory. So that is the meaning of tuning out there, Dr. Sayan. Yeah.
And you have mentioned that in the defense implementation, you have used SIEM.
Yeah.
So did it, I mean, improve anything apart from the detection time?
It actually helped to catch the exact anomaly that is going around. Okay, so with the help of raw logs, it is very difficult to identify what exactly malicious activity that is going within the environment. But after the use of SIM, we can be able to identify the exact problem statement or exact issue that is happening within the logs or within the environment that is there. So that is the help that we can get through the SIM solutions.
Okay. Thank
Yeah.
you. No more questions related
Thank
to
you,
this.
Dr.
Thank you.
Sayan. Thank you.
Thank you so much for your presentation. So, we'll be moving on to the next presentation now. Next, we have Rajeshwari to present the paper titled AI and Inner Peace, AI Powered Mental Wellness Through the Teachings of the Bhagavad Gita. Are you there, Rajeshwari? Rajeshwari, are you there? Okay. So next we have Noora Mohammed to present the paper AI-driven disease surveillance and outbreak response, a transparent informatics framework for resource-limited healthcare systems. Are you there?
Yes, ma'am. I'm there.
Yeah,
Can I share my screen?
Yes, you can share your screen and you may please begin with your presentation. Please start.
Okay, are you seeing the screen?
Yeah, I can see the screen.
Okay. Good day, everyone. My name Noora Muhammad Sani. I'm here to make a presentation on AI-driven. Sorry, I'm coming. On AI-driven disease surveillance and outbreak response, a transparent informatics framework for resource limited healthcare system on this conference, fourth World Conference on Information System for Business Management. It's not moving. Yeah.
Hello?
Yeah, sorry, I'm having issue with my system. The slide is not moving.
Okay. So do you want to present later?
Maybe the second, yeah, let me just correct the issue. I will present it later.
Okay, so you can stop presenting now.
Ma'am, excuse me, I am co-author with this paper. So
Okay.
can I share this presentation by my
Yeah.
end? Let
Yeah,
me try.
sure, no problem. If you're the co-author, there's no problem.
Yes. Ma'am, is this visible?
It is visible now.
Okay. Nura, you can go ahead. All the best.
Okay. Good morning, good evening, good afternoon, everyone. As I said earlier, my name is Nora Muhammad Sani. We are here to make a presentation on a paper titled AI-Driven Disease Surveillance and Outbreak Response, a transparent informatics framework for resource-limited healthcare system on the Fourth World Conference on Information System for Business Management. Next slide, please. So here, as you can see, is the outline of the presentation. We have the introduction, existing approaches, till to the last one, references. Introduction, please. So as you can see here, the focus of this paper is to create AI smart early warning system for disease surveillance response in limited in current country with limited resources. So effective disease surveillance and outbreak response are high public health priorities, particularly in resource limited healthcare system. The problem of the traditional disease surveillance resource limited is number one, next. Number one, they are slow and manual. They are slow and manual in the sense that if a patient comes to the hospital and he's sick, and then the medical personnel realize this patient is a cholera patient, so he has to write a report and send it back to the, send it back to the center, reporting that maybe there is a case for cholera. By the time for them to process that information and send it back and send the resources to stop this outbreak that's going to happen, it take time. So this will lead to reactive action, which is being taken always after the outbreak is being happened. And then they're having issue with lack of staff, funding, and infrastructure. If you go to some hospital, especially in the if you go to the hospital, especially in the rural areas, you find out that they don't have a lot of equipment in the hospital. They don't have enough doctors. If some patients are brought to the hospital without enough doctors, you see some patients are being put on ground because they don't have enough funding. So in order to move from reactive slow system to proactive system, this is the thing that we want to address in this work. So there are a lot of opportunities using artificial intelligence because it offers capabilities for rapid data analysis, pattern recognition, and predictive modeling. A lot of researchers have been working in this area using artificial intelligence to solve this problem. So our objectives here is to use this AI and develop a novel, transparent, and scalable artificial intelligence-driven framework to enhance early detection, accurate forecasting, optimization, resource to infection disease outbreak in low resource settings, like in developing countries, rural areas, those that don't have this kind of resources. Next slide. Next slide. So existing
Great goal.
approaches
Yes.
are related work. So some researchers have been seeing potential of artificial intelligence to solve this kind of problem. Like this, we have some research that carried out in 2017 in Uganda, a system that analyzed social media and news to get early warning for disease like Ebola. They carried out research in this area, and then recently in Italy, they use AI using satellite image to predict area at risk for the Zika virus. And then in Thailand, also they carry out similar research, but they have common focus. Most of them, like this Uganda system, they are great for analyzing news to detect outbreak. And this for this one from Southeast Asia, their model is great for weather-based prediction. But health official doesn't face just one problem; they face them all. They need a system that can work at once. Make prediction and then give recommendation on the best way, on the best action to take to tackle the problem in the existing approaches. So these are some of the problem as we have here. We have a selected solution. Most of the previous work, they work on maybe they build a model to tackle one disease, or they use one single data source. They didn't integrate multiple sources of data, like data from social media, data from hospital, data from maybe weather data. And then the second one, we have black box model. Many AI systems here are not explainable in the sense that if they are not explainable, which reduce trust and adoption among healthcare officials. What we are saying here is that most of their model, they will just give prediction saying that maybe there is an outbreak, but they will not say the reason. They will not give maybe recommendation. They will not give maybe optimization about how are they going to share their resources. And then high resource demand. So all these AI model, they require high computational computers, and then they require constant internet. So most of these limited resource areas, they don't have this kind of equipment to handle this kind of system. So they need system that can work in these areas. Next slide. So in order to overcome all these mentioned limitation above, we have this methodology that we propose. Before we built our model, we collected data set from 4 sources, from electronic healthcare records, syndromic surveillance data, environmental data, social media data. After we collected the data set, then we integrated them into central repository. Then we went ahead and then developed our models. So here we use 3 model. We use outbreak detection model, forecasting model, and then intervention optimization model. For the outbreak detection model, we use isolation forest model, and for forecasting model, we use long short-term memory, and ARIMA. We also use Bison network model, and then we assemble them using boosting algorithm. So after all these models they have worked, they will present the results to the public health official. Then they will take the necessary action to what is happening. Maybe if it gives prediction, maybe in a particular village, there will be an outbreak of Ebola or cholera in the next 5 days. Then the public official will take action against this problem. Next slide. Next slide.
Yes.
So
I think
after
there
we
is some
successfully
internet
developed our
issue.
model, we evaluated the performance of the framework using this matrix. We use R square to evaluate the forecasting model. We use classification accuracy to evaluate the outbreak detection model, and then we also use area under the data receiver operating characteristics to evaluate the initial performance of the model. So all this, the median detection time of the model is given 3 days early warning before the outbreak happen. Before the outbreak happen, the model will give early warning of 3 days. Then the medical personnel or the health official will try to look a solution before the 3 days come. They will look for a resources and then send it where it required, so that when the outbreak come, they have already prepared for it. Next slide. Next slide.
Yes, it's
So
already
this
happened.
is the comparison analysis of traditional versus our AI-driven surveillance system. As you can see on the early detection, our model achieved accuracy of somewhere around 80%, but for that of traditional one, they achieved somewhere around 60%. When it comes to result allocation, our own model achieved almost 80% of the accuracy, but the traditional one achieved somewhere around 45%. When it comes to resource allocation, or sorry,
Sorry to
response time.
interrupt you. Sorry to interrupt you, but you have 1 minute to conclude your presentation.
Okay, thank you so much. So when it comes to resource response time, our model has an accuracy up to 80%. It can respond in short time, and then the medical personnel take action when it required. And then when it comes to most cost efficiency, it has an accuracy of almost 80% against the traditional model of 60% accuracy. So we are talking about cost efficiency. That's why limited resources, they have problems. So this our model is cost effective. So in conclusion, we have created a complete, transparent, and effective AI system for disease surveillance. It is designed specifically for areas with limited resources. In future work, we want to expand this framework to cover a wider range of infection diseases like Ebola, like maybe malaria and other diseases. And we also want to integrate data from mobile health apps and IoT devices in our future research.
Thank you so much for your presentation. Sir, do you
Yeah,
have
thank
any
you for listening.
questions? Do you have any questions?
Yeah, I have a couple of questions regarding the presentation. Uh, uh, what I learned from your presentation is it is more about the AI based, it is more about the surveillance rather than outbreak response, because I did not find where it is responding to is the system completely implemented, or is it only detecting the outbreak or something like that? Or this is my first question, that whether it is only limited to the surveillance or the outbreak response has also been, implemented in your system.
Yeah, the model is we just after we train the model, we try to create interface to just make an implementation like to test the model. So we implemented the model like testing. I have the interface here. If you like, I will show you the interface how it's working. So we use isolation forest for the response. When when it detected the let's assume we have maybe in cases in the hospital every day we have 15 cases of cholera every day 15 cases, and then one day then it rises to 45 cases. So the model will alert the health official saying that there may be an outbreak that will happen because of this unusual pattern that we have seen. So then it will go ahead and give maybe forecast how many weeks it's going to take for it to happen. So that's how it works.
Okay, so it is more about forecasting or predicting about the outbreak rather than it is responding to it, isn't it?
Yeah.
Yeah. My second question is that you have mentioned about the different types of data that you have used, but I did not notice that what kind of data that you have used, like for any particular specific disease or any particular time range, for example, for last 3 years, 4 years, what was the specification of the data? Can you mention that?
You're talking about the type of data we use?
Yeah, the data that you have used in your study.
Yeah, here we work with one private health organization called here in our country. It's one. It's called Go Health. Is an organization that's it is a health organization with our government and World Bank. So we work with them to to get the data set from them. So I don't have this the number of there's a number of data, the specific number,
No,
the
I'm
exact
not.
number of the data set we use, they are large because it's privacy, because of the privacy.
Yeah, I get it. I'm not asking about the numbers or the data points. I'm just asking whether it is a data of certain range for some certain range, like 5 months or 5 years or 50 years. What is the
Okay,
range?
yeah, it's certain range. It's better that it's gathered for certain specific years. It's not data for maybe, it's gathered maybe 2 years and above.
Okay. And did you manage to identify any outbreaks from the data? Outbreak of disease, like whatever you are working on. So, was there any outcome of this? That it is predicting some kind of outbreak or something from the last 2 years data?
Didn't get the
that you
question.
have
Can
mentioned?
you come again?
Like you have mentioned that if there is a cholera outbreak or
Yeah.
maybe a COVID-19 outbreak, so from the last 2 years data that you have worked upon, did you find out any such diseases that might cause an outbreak? That's what I'm asking.
I didn't hear the question correctly. You said from last.
From
Can
the
you
data
please?
that you have worked upon, the data you have worked upon, was there any case of outbreak of any disease? That's what I'm asking.
Okay, yes. The data that we work on, there is data that contain outbreak of cholera. Sorry, yes, there is.
Okay. That's what I was asking about the
Oh,
disease,
sorry,
not
the
about.
network is just cracking. I didn't get the question. It's from the network.
Okay. Thank you for the presentation.
You're
No
welcome.
questions from my side.
Okay, thank you for the presentation. You have reported your overall accuracy of 94.8. Could you explain the cross-validation or external validation methods you have used to ensure that the results are not data specific?
You said what? Excuse?
What can you just explain to me the cross-validation or external validation methods you use?
Cross validation.
Yes.
So I didn't understand this question. In this work, I didn't mention any cross validation or external validation. I didn't get the question.
Okay, maybe you can just explain to me how does your framework handles false positives or false negatives in the outbreak detection?
Okay, I understand your question. So here, after we train the model, we use receiver operating characteristics so that the model is somewhere around 94% in handling false positive and false negative percent.
Okay, thank you. Thank you for your study.
Yeah.
Thank you so much for your presentation. We'll be moving on to the next presentation. I request
You're
all the
welcome.
presenters to please keep their presentation ready and please mind the time. Thank you. Next, we have Rajeshwari to present the paper title AI and Inner Peace, AI Powered Mental Wellness Through the Teachings of the Bhagavad Gita. Rajeshwari, are you there?
Hello, good afternoon. Can you hear
Yeah.
me?
Yes, Rajeshwari, can you please start with your presentation?
Yeah, thank you. Myself, Dr. Rajeshwari SB, Assistant Professor from Department
Please
of
share
Inform.
your screen.
Screen is shared already.
No, it's not visible. Can you share it again?
Yeah.
Yeah, now it is
Okay.
visible. You may please start.
Okay, fine. Yeah, my paper title is AI and Inner Peace, AI-powered mental wellness through the teachings of Bhagavad Gita. So these are the topics I'm going to highlight in today's session. That is introduction about the overall project, what I have carried out, and about the Bhagavad Gita, because this is a very saga text for the Indian Hindus actually. So other country people may not be knowing. So that's why I just want to give brief introduction about the Bhagavad Gita and the proposed work carried out, results, and conclusion on the future enhancement. Yeah, introduction. In today's world, we know how fast-paced it is. People frequently experience high level of emotional distress and loneliness and depression, and struggle to access personalized mental health support. So traditional mental health services often face challenges such as limited accessibility and a generalized approach, which can overlook individual emotional nuisance. This one-size-fits-all method failed to address the specified needs of the individual. So the need for more responsive and individualized mental health resources has never been greater, highlighting the importance of innovative solutions that offer contextually relevant and personalized care. So mainly we are developed a chatbot, which actually the prompt what I am giving, that will be connected through the Bhagavad Gita, and the relevant consoling dialogue will be extracted from Bhagavad Gita, and it will be given as a response to the user. So here, the Srimad Bhagavad Gita, a timeless spiritual text, offers profound teachings on managing emotions, finding purpose, and maintaining balance in life. Our project aims to develop a mental health conversational assistant that provides users with motivational responses rooted in the wisdom of the Bhagavad Gita. So about Bhagavad Gita, I would like to say some few lines. Here, the Bhagavad Gita is a sacred Hindu text and a spiritual guide framed as a conversation between Prince Arjuna and God Krishna on the verge of a great war. It teaches that the soul is eternal and separate from the physical body. Krishna advises Arjuna to understand his duty, perform it without attachment to the results, and offer all actions to God to achieve true happiness, fulfillment, and spiritual liberation. The main theme of the Bhagavad Gita is to how to live a righteous and fulfilling life by performing one's duties. That is what we call it as a dharma, with the detached action, that is what we call it as a karma yoga, gaining spiritual wisdom, that is jnana yoga, and cultivating devotion to God, that is bhakti yoga, all while recognizing the eternal nature of soul and surrendering to the divine will for spiritual liberation. That is, people ultimately they expect the moksha, right? There is no rebirth. That is what moksha is called. So our proposed work actually, what and all I have been carried out. So that is first and the foremost is data processing. So here what we are done, I am highlighting only some 2 points because other things are common. That is converting the entire text to the lowercase and doing some other removing punctuations, removing special characters and all. I am not going to highlight under the data processing. So here what we are doing is in the text cleaning part, we were converting the Bhagavad Gita text into a structured JSON where each verse categorized by chapter, verse number, and the translation. So it's a book of verses. Verses in the sense I can say in a simple word like a poems, right? Short poems with for each of the category. Verse indexing, create an index of verses to quickly look up specific teachings based on the user input. So why we are doing this indexing is because it's easy to extract the information based on the prompt what the user has given. We are doing sentimental analysis here, that is on the Bhagavad Gita text. So we are classifying it as different categories of emotions called as a Shringar, Hasya, Karuna, Raudra, Veera. In the bracket, I have put the equivalent or synonym words in the English. So these are Kannada words or Sanskrit words, I can say. Bhayanaka means fear, Bibhasa, disgust, Abhudata, wonder, Shanta means peace and this, Hasya is joy or laughter. Perform the sentiment analysis on the verses of Bhagavad Gita and categorize each verse into 1 or 2 emotions based on the ancient Indian concept of Navarasa. There are 9 emotions are there. That is what we call it as a Navarasa. Nava means 9. Rasa means emotions, which include the following emotions. Sentiment analysis was performed using the Vedar library. Sentiment classification results, if it is a the score is greater than or equal to 0.05, we call that as a positive sentiment. If it is less than or equal to minus 0.05, we call that as a negative. If the score is in between, then we call that as a neutral. A keyword-based approach was utilized to classify the verses into the emotion categories. A predefined list of keywords related to each emotion was matched against the text of each verse. For example, words like love, beauty, and affection would classify a verse under Shrungar. Why? Because if you look at the classification here, Shrungar, the first emotion, the Shrungar, it is actually whenever the keyword what we have in the prompt the user has used, that is love, beauty, that then we are attaching that to the Shrungar verse or Shrungar emotion. If multiple emotions were detected, then we will be taking only the 2 highest score emotions to make it the model simple. In cases where multiple emotions were detected, the first 2 matched emotions were chosen. If a verse matched more than 2 emotions, additional emotions were discarded to maintain the simplicity. Sometimes what happens, the prompt what we are giving, that may match to the multiple emotions. So in that case, the 2 topmost highest score emotions we are considering for giving the response. The final result was stored in a structured JSON where each verse was assigned its sentiment score and corresponding emotions. This format made it easy to interpret the emotional essence of each verse while retaining the contextual information like a chapter and the verse number. So emotion detection, user emotion detections. So here, Hugging Face emotion detection model is utilized to analyze text and identify emotions such as sadness, joy, fear, and others. The model processes the user input, the prompt what we are giving. From that, we are going to extract the emotions, and that will be linked to the corresponding verse number or the index in the Bhagavad Gita, and generates an array of emotion labels, each associated with a confidence score. The emotion with the highest score is selected as the most prominent. For example, if we say emotion labels, categories of emotions can be sadness, joy, or the anger. Confidence score is probability corresponding to each of the detect emotions. A function named detect emotion was developed to interact with Hugging Face APIs. This function processes user inputs and detect the most prominent emotion by analyzing the return labels and the score. The highest scoring is emotion is used for further processing and ensuring an accurate emotional response. Emotion detection alone is not sufficient because sometimes what happens is the prompt what we are giving, in that there may not be any emotions. If you look at the example, what is the meaning of dharma? The user asked the query, given the prompt saying what is the meaning of dharma, there is no emotion, right? So he is expecting some information about the dharma. So in that case, we are not looking at the emotions. To address such type of things, a keyword based search mechanism was introduced as a fallback method. This approach is triggered when no dominant emotion is detected or when the user's query includes specific concepts. A function named find
Sorry to
versus
interrupt you,
yes, ma'am.
Sorry to interrupt you, but you have 1 minute to conclude your presentation.
Okay, thank you. Semantic understanding, I'll go to directly to the results part because only 1 minute is left out. This is the front end we have used the React application. So using that we are developed here. Yeah. Yeah, if you look at the results, this is some screenshots I'll show you. This is our virtual assistant page giving the prompt. So we are calling this app name as Mano Vaidya. So we are given some Kannada word for that. So that means psychologist, we can say, right? Okay. What bothers you? Because if you look at the Bhagavad Gita, so Krishna will be always addressing the Arjuna as Vatsa, right? Vatsa means son or kid, something like that. Okay. So what bothers you? That is the prompt. As soon as you open this app, you'll get that prompt. So here I am writing, the user has to put the query. I am depressed because I have no job on the house. One of the user has given this prompt. So we'll see what result we'll get. So this will be actually, the sentiment will be extracted from this. The sentiment says that the particular person is depressed because of no job on the house, right? So this will be linked to the emotion what has been mentioned in the Bhagavad Gita under the category sadness, right? Depression is nothing but sadness, right? So from there it will extract, and we are using the backend on natural language generation, NLG, generative AI. So that actually takes the emotion and connecting that to the Bhagavad Gita, it will generate its own paragraph or the sentence and it will give it as a response. See here, the prompt what the user has given is, I am depressed because I have no job on the house. So the result what we got from this chatbot is, Vatsa, I understand your distress. The lack of a job and a home can be deeply unsettling. But remember, the Bhagavad Gita teaches us that true happiness lies not in external possession, but in our inner state. As chapter, so we are mentioning the chapter number also and even the verse number also, that says that neither happiness nor unhappiness comes from external sources. These are merely feeling experience that arise and pass away. This doesn't mean ignoring your situation also. It's a call to find peace within even amidst challenges. The Bhagavad Gita also emphasizes the importance of karma yoga, selfless action. In chapter 3 and verse 20, Krishna says, perform your duty, but do not be attached to its fruits, right? So focus on finding work, even if it's not in our ideal job. Every step, every effort is a form of karma yoga. Seek out opportunities, utilize your skills and have faith. You are not alone, Vatsa. Remember, the journey towards a stable life is a process, and with a perseverance and faith, you will find your way. This is a kind of like consoling by taking the what has been discussed in the Bhagavad Gita, right? So when you listen to this, so when you read this, the person who is under the depression, so he can feel somewhat consoled, right? So here the conclusion is, so this is showing some 85% of good results. So relevant information only is extracted here. The question asked is, I am depressed because I have no job on the house. This is the prompt, right? So if you read this text, what has been extracted from the Bhagavad Gita and given as a response from the chatbot, so that is relevant to that, right? So the quite result is interesting and it is satisfactory also. So in the future, you can put more into the deep learning concepts. Here we are not much involved in the deep learning concepts. So you can enhance this work and you can make, and also what you can do is you can, by looking at the condition of the user who is under the depression or whatever the problem he is facing, he or she is facing. So you can connect it to the counselor also. So that also you can integrate as part of this work. So here integrating both the chatbot with professional mental health services or crisis support systems would provide users with additional resources in case they need more than spiritual guidance. This chatbot is giving only the spiritual guidance. So you need any other than that if the person is not consoled, right? So then you can attach that to some doctor, counselor, so that you can find it results, right? So that is this they can enhance and they can fine tune it also as a future enhancement. So these are the references we have used. And yes. Any questions?
Okay, I have a clarification. Does your chatbot only accept English or
Yes,
any
sir.
other
Yes, sir,
language?
English. So we
Oh.
actually tried for other languages, but as of now, we have done only for the English. That also can be done as future enhancement.
So how do the chatbot check on the effectiveness of the other language or multilingual? So it's not possible.
That we have not tried because English is the universal language. So first we tried with the English, and we are in a discussion to do that for our Kannada regional language. So my mother tongue is Kannada. So we are planning to do for Kannada also and now even Hindi also.
Okay, it's a very good start. Thank you.
Thank you.
Sir, Sir RJ,
Yes,
am I
ma'am.
not
Yes, sir.
lost? Am I in this group?
Yeah, yes, sir. Actually, you'll be the next, sir. You're still on
Okay,
the
thank
fourth.
you.
Yes, sir,
Still
you
on the
Thank
got
you,
fourth
it.
thank you.
question, sir.
Okay. So we're done with the presentation, I guess. So we'll be moving on to the next presentation now. Okay. Next, we have Aldefo to present the paper title Forecasting Cryptocurrency Trends, Applying ARIMA and Machine Learning to Predict XRP and Bitcoin Prices. Are you there, sir?
Sir Ariba, it's your turn now.
Okay.
Yeah.
Can I be heard?
Yeah,
Yes,
yeah.
can be heard.
We
You
can
may
hear you.
share your screen now.
Thank you, thank you.
Thank you.
So let me share my screen first.
Yeah.
Okay. I'm sorry. Oh, what? So, wait. Where shall I? Oh, yeah, okay. Sorry. Huh? Am I shared now?
No, it's not shared, sir.
Oh, what happened? Sorry, but something is wrong. Okay, wait. There's some. Okay, I already have. Oh, okay. Yes. Oh, why am I not? I'm I'm actually trying to. It's already in the share that I am, but it is.
Can I share
Can
your
you
slide, sir?
reshare? Can you reshare?
Uh yeah, I'm trying to share, but why is it that it's a different wait.
So just stop sharing and then you can, click the
Okay,
share
wait.
button. Yeah, yeah.
Maybe this one. Okay. Um Sorry. Okay, go back to I okay. Why? Okay, this one. Rima to share. Can I be seen now?
Yes, sir. Your screen is visible now. You please may begin.
Okay, okay.
Yeah, yeah.
So thank you. Okay, so I'll now start with my presentation, and let me introduce myself. First, good afternoon, everyone. I am Professor Adolfo Arevalo, and today I will be presenting our study titled Forecasting Cryptocurrency Trends Applying ARIMA and Machine Learning to Predict XRP and Bitcoin Prices. So, cryptocurrency, such as Bitcoin and XRP, have become some of the most actively traded assets worldwide. Unlike traditional financial assets, the crypto market operates 24/7 with a very high volatility and sensitivity to investor sentiment, news, and speculations. And this volatility makes forecasting a challenging but valuable task. Now, accurate forecasts can help traders manage risk, assist policymakers in understanding speculative bubbles, and contribute to the growing body of financial technology research. However, the unpredictable and nonlinear nature of cryptocurrencies means that no single method works perfectly. And so um, the previous studies on cryptocurrency forecasting often use either traditional statistical models such as ARIMA or machine learning approaches that support vector regression and random forest. But few have directly compared these models using the same data set and evaluation framework. So this lack of comparative studies motivated our research, and we wanted to ask which models are more effective in predicting short-term cryptocurrency price movements. So it's either a traditional statistical method or a modern machine learning models. Now, um, okay. To apply ARIMA, SVR, and random forest models to forecast Bitcoin and XRP prices, and to that is one of our rather main objectives, no, and to evaluate and compare forecasting accuracy and of these models using error metrics such as mean absolute error, the root mean squared error, and the mean absolute percentage error. And also the third objective is, of course, to provide insight into the strength and limitation of each model in handling high volatility markets. Now, we use historical daily price data of Bitcoin and XRP. The data set included, of course, open, high, low, close prices and trading volume. And we pre-process the data by handling missing values, smoothing out extreme outliers, and normalizing where necessary. And the data was then divided into training and testing sets. So the training set is allowed, or rather, the training set allowed the models to learn historical patterns, while testing such a measured predictive accuracy on unseen data. And so as far as the methodology is concerned, no, here, ARIMA which we refer to as autoregressive integrative moving average, is a classical time series model, and it works well with linear trends and seasonality, but it assumes that past values can explain future values, which may be limited in volatile markets. Um, Support vector regression, or SVR, is a machine learning algorithm that maps the data into higher dimension and fits the best regression line within a margin of tolerance. And it is particularly good at handling nonlinear relationships. The random forest regression is an ensemble learning method that builds many decision trees and averages their predictions. And this makes it robust rather to noise and capable of capturing complex linearities. So the to assess the model performance, we use three common forecasting error metrics. We have the so-called mean absolute error, or MAE, which measures the average absolute difference between prediction and actual values. We also have the root mean squared error, or RMSE, which penalizes larger error more heavily, and also the mean absolute percentage error, which provides percentage-based errors for easy interpretation. So using multiple metrics ensured a fair and comprehensive evaluation. Now, results, as far as Bitcoin forecast is concerned, for Bitcoin forecasting, Arima provided a good baseline but struggled during sudden price shocks. The SVR improved accuracy by capturing nonlinear dynamics, especially during short-term fluctuations. And the random forest, however, performed best overall, producing the lowest RMSE or MAPE. So this suggests that ensemble learning is more suited to handle the noisy and nonlinear nature of Bitcoin price movement. But as the results suggest, the best model here is Arima, as seen by the as can be seen from the table. The Arima has the lowest of MAE and MAPI and also RMSE. So if in the case of uh, XRP, for example, Arima is the best. In the case of Bitcoin forecast, also Arima rather is considered the best. So for for XRP Arima, again, it proved to be the most accurate model, producing very shall we very minimal forecasting errors, and so the random forest came close with, but with slight higher error values. And on the other hand, of course, the SVR struggled with excess volatility, resulting in significantly higher errors. And this shows that Arima works best for XRP as well as in Bitcoin. Now, the findings, of course, carry important implications. So as you can see from the chart, Bitcoin forecast versus actual Arima, this is much more accurate. Okay, and we also have here the use of Arima for forecasting XRP prices, and there is that bigger error that you can notice from the graph. Bitcoin forecast for actual random forest also has this error. And so when we combine the results of both Bitcoin and XRP, Arima still ranked the best overall with the lowest average errors across Bitcoin, while SVR consistently produced weaker result, especially for XRP. And this ranking shows Arima's consistency and reliability. So to conclude, Arima consistently outperformed SBR and random forest. and in forecasting Bitcoin and XRP short-term prices, and it is therefore recommended, to anyone who are needing reliable short-term crypto forecast. But the model should be chosen based on asset type, updated, and it should be
Sorry to interrupt you, sir, but you have 1 minute to conclude your presentation.
okay. Thank you. And so ultimately, these forecasting tools can guide investors, and analysts and decision makers towards smart and more informed strategies. So thank you.
Thank you so much for your presentation, sir. Session chair, sir. Do you have any questions?
Okay.
Yeah.
Hello, sir. Sir.
Yes, sir.
Yes. Good afternoon in the
Yes, good
Philippines.
afternoon.
Okay. So given that Arima's strong performance, did you notice any significant difference in the performance of BTC and XRP? That might
Yes. As far as Arima is utilized for BTC and XRP, it is best to use Arima for BTC rather than XRP. You can see from the graph that the noise, the noise for XRP using Arima is bigger than that of the noise for using Arima on Bitcoin. The level of accuracy is very it's more or less perfect, for Bitcoin using Arima.
Okay, so what will be your future study scope, sir? Since you're just mentioning about short term.
Yes, because I just consider the short-term analysis of the prices of these assets. So maybe I can be able to do more research, trying to make a long run analysis as to whether this kind of forecasting models will still work even for like weekly, monthly, or yearly trends.
Thank you very much, sir. Ariba.
Thank you. Thank you.
Yeah. Hello, sir. I have a couple of questions regarding.
Yes.
Yeah. First of all, I'd like to ask you that did you find any reason that why Arima performed better than other models compared to Random Forest or SVR? Was there any reason?
Because Arima provides interpretability and a strong statistical baseline, and it helps us understand how much of the crypto trend can be explained by linear time series patterns before adding complex machine learning models.
Okay. About the question, Professor Dr. Randy also asked about the future scope. Are you planning to include any other models to your study?
Yes, in fact, I was working about not just the ARIMA, but in my other research paper, I also tried to consider other methods for trying to compare, of course, the long run and the short run volatility. I mean the low and high volatility assets using different other models.
Okay. Glad to hear that. Nice presentation and congratulations, sir. Thank you.
Thank you, sir.
Thank you so much for your presentation. We'll be moving on to the next presentation now. Next, we have Rajeshwari again to present the paper title, Gesture and Speech Enabled Virtual Mouse for Assistive Human Computer Interaction. Rajeshwari, are you there? Rajeshwari?
Yeah, I am here. Audible?
Yes, you may please begin with your presentation.
Yeah,
And I request all the participants to please keep the track of the time. The time limit is 10 minutes. Thank you. Please start.
Is it visible now?
Yes, it is visible. Please
Yeah,
start.
this is my second paper for in this conference. Title is Gesture and Speech Enabled Virtual Mouse for Assistive Human-Computer Interaction. So the main agenda I'm discussing, giving brief introduction about that, and the proposed work I'm discussing, implementation, results, conclusion, and future enhancement. So here what we have done is we are giving both voice command and the hand gestures. The main purpose, if you look at the diagram here, the model, we start with the Jarvis interface. So we give the voice commands and we can give the hand gesture model also. It finds out what actually the gesture is telling, and based on that, it will try to make the cursor movements on the system. So the system will start with the Jarvis interface ready to accept the voice command. User can give voice commands to perform specific operations like list files, copy, paste, know the current date and time, etc. This interface further can be used to launch the hand gesture module, which can be used to control the mouse using hand gestures by detecting the camera, and the video interface will be started. The camera can extract and recognize human hand gestures from video interface. Various hand gestures can be used to perform various operations like move, left click, right click, double click, scroll, etc. Hand tracking functionality is done by the MediaPipe framework for Python. After the recognition, the cursor moves accordingly to perform various operations. The main purpose of doing this is this innovative system leverages real-time video and audio inputs to interpret user gestures and voice comments, thereby eliminating the need for conventional input tools and for users with the mobility impairments. Its reliance on standard webcam and microphone hardware ensures affordability and widespread accessibility. So instead of going for the gloves are a bit expensive, so we can use with the hands and along with the normal webcam, not the high standard, high configuration webcam is not required. The development of this system not only addresses existing interface design limitations, but also underscores the broader goal of HCI to optimize user experiences and expand digital accessibility for all individuals, regardless of their abilities or environmental constraint. The main purpose is the people who are mobility impairment, right? So they can use it. And if you don't want to use the physical devices, right? So for that purpose also, you can go for these hand gestures. So hand gestures, the system utilizes MediaPipe, a state-of-the-art framework developed by Google, which implements CNN for real-time, high-fidelity tracking of hand gestures through the standard webcam. This is complemented by OpenCV Python, which actually is for image processing and the gesture recognition task. So we are, along with that, we are doing it in the, if suppose the low light conditions, in that also the model or the app could able to detect the hand gestures. So that also we have worked on that. The integration of dark channel prior and bilateral filtering into the image processing pipeline ensures that the system can effectively handle low light conditions and improve the accuracy of the gesture recognition. Because if you look at in the why we have focused on the low light condition means keeping in the mind, like in the rural areas, most of the time the electricity will be down, right? So there the people who are actually nowadays it is a work from home concept is there. So there the people, if they want to go for the hand gestures, so then even in the low condition also, so they can go for the low light condition also, they can use this app. Voice command along with the hand gestures, you can give the voice command also. By integrating both, we are expecting the more performed results. So voice command functionality is integrated through a voice assistant built using Python. This component responds to spoken commands, enabling users to perform complex tasks that are cumbersome with gestures alone, such as opening applications or typing text. Suppose if any gesture is not, machine is not able to recognize, then we can go for the voice command. The integration between the hand gesture and the voice command models is facilitated by PyBind 11, a lightweight of C++ library that provides bindings between C++ used in MediaPipe and Python-based voice command system. This setup ensures that the different components of the system work together smoothly and efficiently, delivering a seamless user experience without the need for additional or specialized hardware. So users interact with their computer by making specific hand gestures in front of the camera, webcam, even in low light conditions. These gestures are captured in real time, processed using DCP and bilateral filtering techniques, and translated into on-screen cursor movements and the clicks. Simultaneously, user can issue voice commands to perform tasks that might be more complex or less suited to gestures, enhancing the system flexibility and functionality. This dual input approach allows for a high acceptable, adaptable, and user-friendly interface, catering to a wide range of user needs and preferences in various settings. Yeah, hand gesture, as I already told, MediaPipe and OpenCV is used. Integration with the DCP and the bilateral filtering is used. And voice command, as we have used one Python, that is assisted. So this is how the flow is, the overall proposed model. So here, now what happens is we are first initializing the system and start the video capturing of webcam. Capture the frames using webcam, then detect hands and hand tips using MediaPipe and OpenCV, and draw the hand landmarks and a box around the hand. These are all the landmarks, if you can see. Yeah. Okay. So landmarks, there are actually totally 21 landmarks are there. So each of the points on the hand, so some points are there. So they are given, named it as. So first it identifies the structure of that, or we can say tip of the finger. And then based on what angle we are making the movement of the finger, based on that, it will perform the particular action. So draw a rectangle box where this is the region of the PC window where we are going to use mouse. Detect which finger is up, right? So we are using index finger, middle finger, ring finger, and the pinky finger, and even the thumb balls. If the index finger is up, or if both index and the middle fingers are up, then mouse cursor moving around the window, right? So if both thumb and the index fingers are up and length between them is below 30 pixels, then perform left button click. If both index and middle fingers are up and length between them is below 40 pixels, perform right bottom click. If both index and middle fingers are up and moved towards up, perform scroll up function. So if both index and middle fingers are up and move towards down, perform scroll down function. If all the 5 fingers are up, no action is performed. So press stop to terminate. So this is what the overall proposed model. So gesture recognition. So sophisticated algorithms are employed to process the raw data captured by the depth cameras and interpret hand movements in real time. These algorithms analyze depth images to detect and track the user hands, identifying specific gestures based on the predefined patterns. To enhance the system performance in low light conditions, dark channel and bilateral filtering technique are integrated. Speech recognition algorithms are implemented to analyze audio input from the microphone and convert spoken commands to text. These algorithms employ techniques such as HMM and RNN to recognize and transfer spoken word accurately. Once user input is captured and processed, the system integrates seamlessly with the operating system to execute the desired mouse actions. This involves developing software interfaces or drivers that bridge the gap between the gesture and the voice-controlled input and the OS mouse control functions. Drivers development is also required. Device drivers are developed to facilitate communication between the gesture, voice, and voice control mouse system and the operating system, because finally the operating system has to do the performance with the mouse clicks. These drivers translate the processed gesture and voice commands into corresponding mouse actions such as cursor movement, clicking, scrolling within the operating system environment. Feedback mechanism plays a crucial role in providing users with real-time information about the system response to their
Sorry to
gestures.
interrupt you, ma'am, but please conclude your presentation within 2 minutes.
Okay, ma'am. Thank you. Visual or auditory cues are implemented to indicate successful recognition of user input and the corresponding mouse actions performed by the system. So when we display our hand gesture in front of the webcam, so once it is correctly recognized, then we'll get a noise sound, right? Some prompt will be given, some with the noise. So that is actually a kind of feedback saying that the gesture has been recognized by the model or the app. Visual cues, visual feedback such as an on-screen indicators or animations inform users about the system's recognition of their gestures and the resulting mouse actions. For example, a cursor icon may change color or shape to indicate cursor movement or the clicking. So we are giving the audio feedback also and the visual cues also. Auditory cues, auditory feedback such as system-generated sound or voice prompts provides additional confirmation of successful interaction with the system. Users may hear a sound effect or voice prompt when a gesture or voice command is recognized and executed by the system. That is an indication that the system is working fine. That means it is got the gesture what I am showing. The implementation of a gesture and the voice-controlled mouse system involves a multi-stage process encompassing hardware setup, software development, integration with the OS, and user feedback mechanism. By combining all these hardware sensors with advanced software algorithms, including dark channel and bilateral filtering techniques, the system enables user to interact with their computers. Okay, I'll go directly to the output results here. So this is what the hand gesture has been shown. So this is to indicate that, see there, the line, these are the 21, there are totally like this red dots you can see, like that you can have 21 landmarks in the hand. So this actually diagram displays a cursor trajectories as continuous lines over a user interface, illustrating the cursor movement patterns captured during the evaluation of a gesture-controlled mouse interface. Each line represents the path the cursor took as controlled by the user gesture. As and when you move, you have to show only the 2 fingers up, right? Rest of the 3 you have to hold it. So as and when you move, the cursor will be moved, right? So this is for right click, you have to show only the index finger. So demonstrate the performing of a right click gesture, performing the interface, mimicking the shown gesture initiatives, a right click operation displaying a contextual menu for selecting actions or commands. This initiative gesture based interaction enhances user experience for navigating the interface functionality. So if you are showing, if the only index finger is up, so that indicates that you want to perform the right click operation. So that is why you can see that pop-up window, right? So drop down list. Pinch gesture. So if you want to make the slide movement from one position to another, window movement from one position to another position, and if you want to increase within that, if you want to increase the brightness in the setting panel, so we have shown here for setting this brightness adjustment, so that you can do using this pinch. So figure 4 indicates using a pinch gesture to control a slider within the interface. Performing the illustrated pinch gesture adjusts the slider position, so allowing the intuitive manipulation of settings or parameters through familiar touchscreen gestures, improving usability and the user experience.
Sorry to interrupt you, ma'am, but we are really short of time. So
Okay.
please conclude as soon as possible.
Yes, ma'am. Last. Figure, this is last one. So this is a pinky finger. So this is actually when the pinky finger is up, that rest of the 4 fingers are folded. So that indicates that you are playing, when you are playing a video, so you can pause it by just lifting up the pinky finger. So if it is paused, when you pinky finger is up, that says that it will start playing. When it is playing using the same finger, same gesture, you can pause the videos. So pinky finger gesture that activates play and pause functionality for a video player in the background. So this is with respect to the dark, right? So low light conditions. So this is, so see here also the app could able to recognize the 21 landmarks, what is there in the hand, right? So machine can recognize even in the low light condition also. And the rest of the operations are same. So same fingers or the gestures you can use to perform the operations. So here we are so totally yes. So by harnessing cutting edge ML and CV technologies, this innovative solution reduces the reliance on physical contact, offering precise and intuitive control through the hand gestures and voice commands. This breakthrough has profound implications, particularly for individuals with impairments who can now interact with the digital information and system more effective. So the results are satisfying, quite satisfying. So here it demonstrates 90% of accuracy in the gesture recognition and 60% accuracy in the low light conditions. And voice command, it is achieving 95% accuracy. Yes. So low light conditions, so they can, the people who are interested in the work, so in the low light conditions, so they can enhance this, because the result what we have got is only 60% accuracy. But rest of the things, it is a 90%. It's a good satisfactory results as per our work. So these are the references.
Thank you so much for your presentation, session 2. So do you have any questions?
Okay. Given with the low accuracy result for the low light condition, I know you're planning how to improve this one.
Maybe because of the light conditions, it's little bit brightness. If it is there more than 50%, it will be quite, results will be good. If it is a below like 30 to 50% of lighting, so then it is showing 60%. Actually, how we conducted is, we are covered in a room with all the screens closed and all, so light switched off, and we tried that. So that is actually giving 60%. And as per our model, it is giving 60%. Later, in any other methods, if they include, so they may get better results.
Okay, thank you.
Thank you, sir.
Sir, do you have any questions?
Yeah, just one question that did you make any comparison with the previously existing similar models? Because we have seen so many models working for the same kind
Yeah.
of human-computer interaction.
Yeah, previously they have done some good works on this, but actually people are not focused on the low light conditions. That we took as a plus point, as a innovative in our work, and also the results are quite more compared to the previous work. So there also they have used what is that bilateral filtering and OpenCV media pipe and all they have used, but our results are better than the existing results. But ours highlight is we have tried with the low light conditions.
Okay, thank you.
Thank you.
Thank you so much. So we'll be moving on to the next presentation now. Next, we have Thang to present the paper title Habit and Perceived Safety on e-wallet Adoption in Vietnam. Are you there?
Yeah, I'm here.
Yeah, can you please present your paper? Will you be presenting on the author's behalf? Yeah, you can share your screen now. Yeah. Please start with your presentation. We cannot hear you. Please unmute yourself.
Can you
Yeah.
hear me clearly?
Yeah, I can hear you clear. You may please begin now.
So, first of all, I would like to send my respectful greeting to Professor and student standing in the defense chemistry of the Fourth World Conference on Information System for the Business Management 2025. And my name is Anne. Today, I'm honestly to present my thesis with the topic Habit and Perceived Safety on e-commerce adoption in Vietnam under the supervision of Dr. Nguyễn Duy Thanh. And my present includes 5 parts: introduction, little theory, review, research method, research result, and conclusion. And in Vietnam, at the research, Vietnam had 18.3 million equal users, with not cap transaction increased by 69.7%, internet-based transaction rising by 48.39%, and the QR code payment up by 56.62%. The number of the active e-commerce account also grew by 10.37%. Other digital payment methods such as bank transfer and QR scanning are also expanding rapidly. By Statista 2024, a regional report by Google, Temasek, and Penn and Company in 2024 indicate that Vietnam digital payment transaction value grew from 126 billion USD in 2023 to 149 billion USD in 2024. And it projects to reach between 300 and 350 billion USD by 2030. Nguyên et al. Embracing the role of the habit in e-wallet users, while Sudan and Rana highlight security and privacy influence acceptance. Habit might act as a barrier with the potentially negative effects. Given this background, study how habit and safety perception shape e-wallet adoption and use have both theoretical and practical relevance, offering insight into users' behavior and dynamic of the digital payment adoption. E-wallets, a digital Wallets, a software application that securely stores users' payment credential and login information for various online platforms. E-wallets enable electronic transactions, including purchasing goods and service online or the physical stores without requiring cash or physical tax. Web technology acceptance model, STEM, EAM, introduced by Davis in 1989, suggesting that an individual intention to use a system is primarily influenced by two reception. How benefit they believe the system will be the improving their job performance, and how a smartness that expects the system to be the turn of users. Influence user attitude and intention towards new technology. Unified theory of perception and use of technology, UTA-UN, developed by Bangkok et al. In 2003. UTA-UT associate a early critical frameworks. The model highlights four primary constructs: performance expectancy, effort expectancy, social influence, and facilitating condition as direct predictor of individual behavior, intention, and actual technology use. To adapt UTA-UN for the customer context, in order to tailor UTA-UT to customer behavior, Bangkok et al. Developed UTA-UT to by the incorporating three addiction variables: hedonic motivation, drive value, and habit. Privacy theory based on the Wesley in 1967, foundational work and Atman in 1975. The psychology perspective, privacy in the conceptual and the individual's ability to control access to their personal information. In technology context, perceived privacy refers to the user belief in their ability to manage the data with each shared with and under what conditions. Strong privacy concerns have been shown to lower trust and hinder the adoption of the digital platforms, particularly in the finance and e-commerce application. Social security, this refers to users' assessment of the safety and the integrity of the digital platform, especially when transmission sensitive or the financial data. Yancy in 2005 iterated that the receiver's security is the primary assessment of trust, with him turn strongly influence behavior, intention, and mobile payment system. When finance stakes are high, the security play a powerful role in the user adoption decision. And a reality analyst 5-factor with 19 item bridge probability are included in the formal study. Two factor, two independent factor, two mediating factor, and one dependent factor. The model includes 6 hypotheses. For example, perceived security had a positive impact on the intention to use e-wallets. The research project divided into 2 stages. The first stage involved preliminary research using qualified method, and second stage employed formal analysis with the quantitative method. During the first day, a graph scale is developed based on the theoretical foundation of the technology adoption and other related thought. The graph scale is then reviewed by senior expert in the electronic payment and in commerce. E-commerce to enhance its content accuracy. In the second stage, the adjusted scale is adjusted by the opposite scale. This stage use a 5-point like fairness questionnaire with
Sorry to
include
interrupt
five-
you, but you have 1 minute to conclude the presentation.
Yeah, thank you. And the measure model assessment. The analysis of the measurement model assessment were tested to ensure that the measurement fully represented the coefficient of the determined following variable function of fidelity discrimination, fidelity for and fact, and composes reliability are analyzed. And that is the exploratory texture analysis and confirmatory texture analysis results. The structure equality model decay and habitus result. And in conclusion, this study explores how the security, the privacy, and how to influence equality user implementation and behavior in Vietnam based on TAM, UTAUT, and UTAUT2, a framework perspective with data from 265 respondents. Results show that habit and the ship security significant impact and tension was strongly predicted actual use. However, the security had no significant effect on application, and neither had nor security directly influenced users, highlighting the military role of the inflation. For the e-wallets provider, the finding of the security insight focus on enhanced security through transparent impression, skill locking, and visible sensitivity measure to build the user's habit, implement the report system, seamless interface, and different transaction insensitive to integrate e-commerce into the user daily routine. And limitation and future work. What study offer literary insight and this had a limitation the same were limited to Vietnamese cities and the area. Why may not represent the above Vietnamese populations? The reported data may interrupt that and the craft, traditional design limits casual in field. Future research should explain geography and demography, cooperate, use long cynical design to accept possibility and explore additional factors like trust, usability, and finding literacy for the more continuous understanding of the equals and adoption. And that's the conclusion of my presentation today. With my limited experience, this research might still have a shortcoming. I truly hope to receive feedback and comment from professionals.
Thank you so much for your presentation.
I'm so sorry because I'm not feeling well today with my headache, so my present might not very good. I hope you're understanding. Once again, thank you very much for your attention and listening.
Thank you so much for your presentation. Sir, do you have any questions?
I don't have any question, but I have a recommendation. Okay, your study is maybe you could try to consider other respondents in the future in not in some part of the Vietnam, maybe in a place that technology is not yet much implemented as part of your future study. So that would be all. Congratulations in your presentation.
Thank you so much.
Thank you.
I guess no further questions. We'll be moving on to the next presentation. Next, we have Nureni to present the paper titled Machine Learning Algorithms for Detecting Fake News on Social Media. Nureni, are you there? So next we have Akash to present the paper titled Real-Time Deepfake Audio Detection Using Lightweight CNNs. Akash, are you there?
Yes, I'm here.
Yeah, you may please begin with your presentation.
Yes. Just a
Kindly take a
second.
note of time.
Yes. Just a second. Is my screen visible?
Yeah, your screen is visible. You may please start now.
Yes. So good afternoon, sir. I'm presenting the topic real-time deepfake audio detection using lightweight CNN. So the authors are obviously me, Akash Karoya, and Prathvina ma'am. She is not currently present over here, but I'm going to present. So the outline of my presentation is going to be introduction, literature review, methodology, system architecture, contribution, and comparison with the existing system. So let's get started with the introduction to deepfake detections. So let's first understand what is deepfake audio detection. So basically, a deepfake audio is AI-generated voice that mimics a real person. It's basically created using text-to-speech, voice cloning, or generative models like GANs, wave-to-vectors, or vocal coders. It can be used for scams, misinformation, and identity fraud. The importance of detecting deepfake audio is first security risks, like someone can impersonate your relative and do some scam with you. The second is like financial frauds, and the third is cyber crimes. Like we nowadays we see the fake calls that are being surfaced on internet. Second is misinformation, like spreading fake news or manipulate any evidence which is not actually true. The third is privacy concerns, like unauthorized cloning of voices, which they don't have access to. The third is mechanism of deepfake audio detection. The extract in deepfake audio detection, extract features from audio signals. We basically use mail spectrograms or MFCC, using machine learning and deep learning models like CNN, RNNs, and transformers, and classify if the audio is real or fake based on the patterns and artifacts. So the motivation for the deepfake audio detection is like growing threat of deepfake audio. Like AI generated voice can impersonate individuals with high accuracy. Like they are used in fraud, misinformation, identity theft. Increasing use in politics, cyber crimes, and social engineering attacks. So the need for the real-time detection is like immediate threat response, like prevent scams and fraud, so we don't have to waste too much time on detecting if it's true or not. Live applications like in banking, security, like phone verification. If the call, we can detect if the call is it's AI or real or fake or not on the go. And in media, we can use it in news and other applications. So the scalability for real time is like detect deepfake on devices like edge devices like mobile or embedded systems like IoT without cloud dependency. The advantages of using lightweight CNA is like traditional model like ResNet, LSTMs are too heavy for real-time use, and they are the computational power. We need too much more computational power, so it will take time to detect if it's real or not. CNN can process spectrograms faster with high accuracy, as spectrograms are male spectrograms or spectrograms are images, so it's CNN is perfect in doing it. Optimized, and it is optimized for mobile and embedded systems. Like we can use TensorFlow Lite to make it live on edge devices. Research significance is like filling research gaps. Like most deepfake detection models are resource intensive, and then like enhancing securities like mobile-based detection help prevent fraud in real time. And future proofing is like AI generated audio is evolving. Robust detection is essential. Let's just go to literature review. I'll be not going through every papers. I'll just show what papers I have referred to. So the first one is a review of a modern deepfake audio detection. So the concept of that paper was comparative survey of deepfake detection models using GANs and CNN. The second was a deepfake audio detection using spectrogram-based feature and ensemble of deep learning models. It combines CNN and ResNet based on ensemble models for robust deepfake detection. The third one was deepfake audio detection techniques using deep convolutional neural network, uses deep CNNs for multi-domain features extraction and classification of deepfake speech. The fourth one is detecting deepfake voice using explainable deep learning techniques. It uses LSTM and explainability methods for explainable AI. The fifth one is exposing deepfake videos by detecting face wrapping artifacts. Uses CNN-based spatial image feature extraction. Is someone trying to speak? Hello?
Yeah, you may continue.
The sixth one is fake sound deepfake general audio detection. Uses an end-to-end CNN model with spectrogram feature extraction and data augmentation. The seventh one is from audio deepfake detection to AI-generated music detection. Explores spectrograms based CNN models for both deepfake speech and AI-generated music detections like autotune and all that stuff. Pitch AI-assisted tagging of deepfake audio calls using challenge response. Uses challenge response and pitch-based analysis to detect AI synthesis voice call. Ninth one is the real-time detection of AI-generated speech for deepfake voice conversion, which is the paper I've gone through a lot. Implements a lightweight CNN for real-time inference and detecting AI-generated speech. The tenth one is toward robust real-world audio deepfake detection, closing the explainability gap. Combines deep CNN models with Shapley and waste explainability techniques for deepfake detection. The 11th is Spec RNet towards faster and more accessible audio deepfake detection, introduces lightweight neural networks optimized for fast and efficient audio deepfake detection using spectrograms. And the 12th one is safe ear content privacy preserving audio deepfake detection. Detects audio without analyzing the semantic content by focusing only on acoustic features. The 13th one is a quantum trained CNN for deepfake audio detection. Combines quantum neural networks with CNN to create efficient hybrid deepfake detection, but it's obviously heavy computational power. 14th one is an audio anti-spoofing detection survey. Reviews compares various anti-spoofing algorithms, dataset, and evaluation techniques. The last one is safe call implementing deepfake audio detection in open source communication. This model is basically worked on like the detecting real time like call detecting if it's fake or not in real time on a call. Integrates an LSTM based detection model into live communication app with educational features. So the methodology I'm following is like the dataset I'll be using is ASV Spoof to 2019 is a public benchmark dataset for anti-spoofing and speaker verification ASV system. It focuses on detecting synthesized text-to-speech audio, voice converted audio, and replayed fake speech. It extends this data is an extension of the ASV Spoof 2015 and 2017 with more realistic and challenging deepfake scenarios. Like this datasets contain some background noise and some audio on different settings. So the dataset structure is data is divided into two main tracks, a logical access track and a physical access track. So in logical access track, we see synthetic speech attacks. It includes text-to-speech and voice conversions. It contains both spoofed audio and also genuine audios like from real speakers and in real life settings. Speech is artificially generated using known deep learning and signal processing methods. In physical attacks, the focus is on only replay attacks, like contain recordings made by playing real speech through speakers and re-recording with microphones in different environments, like I've already said. It also includes variations in room size, recording equipment, and background noise and speaker microphone distance. The file format for this dataset is like the audio files are in .flag format, high quality. Sample rate is 16 kilohertz mono channel. Metadata of each file contains file name, speaker ID, attack type, system ID, real or spoof label. The dataset is contains of like spoofed audio is 63,000 samples, and the bona fide like which is the real audio is of like
Sorry to
7,000.
interrupt you, but you have 2 minutes to conclude your presentation.
Yes, thank you. And the real bona fide samples contains of like 7,300 something samples, and it also includes the protocol file which tells the model if it's a real like it is if it's a real bona fide sample or a spoof sample with a fake audio. And the data split is of training set, development set, evaluation set, and each subset contains genuine utterance and spoofed utterance. So going through working a deepfake audio detection model, We can see like spectrograms converts audio into visual patterns, and CNN detects subtle flaws in fake AI generated speech. So the features that it detects, like harmonics, clear natural harmonics aligned across time in real audio, and sometimes missing uneven harmonics in fake audio. The transition in real audio is smooth, and in fake audio it's sometimes abrupt or overly smooth, which is like very unnatural for a human being. Noise patterns, in real audio we can see background noise or breathing audio. In fake audio, there is nothing. The sound is very clear sometimes. The phase information in real audio, phase varies organically, and in fake audio, phase might be unnatural or inconsistent. Pitch variability. Human voice varies slightly in pitch. Synthesized voice may sound flat or very perfect. So temporal patterns are real speech shows natural variation over time, and fake speech may show repetitive or mechanical timing. As you can see, this is how the model detects the patterns, like its inconsistency or consistency. And we can also add additive white noise, which is basically adding a white noise to a already like a pre-made audio, and making the model like go through a test, like if it can detect it's the audio real or not, using like white Gaussian noise. So the model trains perfectly and knows how to detect a fake audio or real audio. How CNN model learns fake versus real patterns, like training phase, you give more pair of inputs, like the spectrogram of real audio is, if the label is 0, it's real, and if it's 1, it's fake. Pattern discovery via convolutions. The CNN starts with random filters like 3 by 3 matrix. It slides over the spectrogram image to detect small patterns, edges, curve, textures. At first, these patterns are meaningless, but as you back propagate the error, the CNN adjusts its filter and detects specific features that help it detect it's fake or real. So the pattern learned by CNN, the pattern indirectly learns patterns like harmonic or phase artifacts by recognizing consistent difference between real and fake samples. So this is my system architecture. Uh, so basically we feed real audio and fake audio into it. And in pre-processing, we first convert the audio to mono channel, and then to male spectrogram image, and then normalize the data.
Sorry to interrupt you, but you need to conclude your presentation.
Oh yes, just this slide and then I'll conclude. The model development consists of convolution layer, max pooling layer, fully connected layer, and activation, software activation. The training is split into data split, evaluation metrics, training parameters, and for real time deployment, we optimize the model and use TensorFlow, right? And for real life inference, and for performance analysis, we make the data go through unseen samples, adversarial attacks, and model comparison. So I'll jump to my conclusion. So the conclusion for this presentation was key takeaways. Deepfake audio poses serious threats in cybersecurity, misinformation, and fraud. Existing detection models struggle with high computational cost, slow inference, and limited adaptability. A lightweight CNN-based approach enables real-time, efficient, and accurate deepfake audio detection. So the research impact for this is provides a fast and resource-efficient solution for detecting AI-generated speech, enhance security in voice authentication, media integrity, and fraud prevention. Future direction I'm looking forward to is like improve robustness against adversarial attacks, expand support for multi-languages and diverse deepfake generation techniques, implement a real-time application in voice authentication system, financial security, and media verification. So these are the research papers I've used, referred to. Thank you. Uh, think- are there any questions?
Do we have any questions?
Yeah, nice presentation. My question is that why convolutional neural network? Why not recurrent or LSTM, but these type of models which are already there?
So as I said, that CNN is very good at detecting images, like some faults in images. And if you use LSTM or RNN, it's heavy computational power, and it the reason behind that real life detection, real time detection won't be there if I use LSTM or RNN.
Have you tried implementing it on your?
Yes, actually, I'm trying right now. I'm currently implementing the project, but the CNN is giving a very fast, and accuracy is above 90. So I might be going with CNN, lightweight CNN. All I can do is like increase the layers in it.
Okay, so thank you.
Okay, this is just a very generic question to you. Since the development of deepfakes is ever changing every day, so what will be your futures plans related to this study?
Okay, so what I'm planning to do is like implementing this my study into so I'm from India, so I don't know if you have the app Truecaller app over there, but in India to detect if which user you are calling, we use Truecaller app. So what I'm trying to do is implementing my model with such app that if I get a scam call or any normal call, the AI takes the 2 seconds audio and detects if it's real or not, and immediately tells me that the audio is real and the person who is speaking is real or not.
Okay. Have you tried this in music? Because there is already
Mus Music.
music AI generated, but I mean
Yes, yes,
music
yes.
generated AI. And
So
if you're familiar with Suno or Yujo, they are already indistinguishable with the human voices, right?
yes, like auto tune, you can also say auto tune, right? Like they use auto tune to enhance their audio. Like in one of the research papers I've studied, they have used the model to detect if the music is like real or made by using AI, or also it also detects if it's using auto tune.
Yeah, yeah. Thank you.
Yes, welcome. Thank you for your precious time.
Thank you so much for your presentation. We'll be moving on to the next presentation. Next, we have Prajodeep to present the paper titled Recognizing Manipulated Images Using Deep Learning in Flask.
Hello.
Prajodeep, are you ready to present?
Yes, good afternoon.
You may share your screen and present now.
Yeah, sure. Am I audible properly?
Yeah, you are audible properly.
Just a minute, I'm sharing my window. Is the window properly visible?
Okay. Yes, it is.
Okay. So, first of all, myself, Prajadeep Patil, and I'm presenting a paper that is recognizing manipulated images using deep learning. Just a minute, ma'am. Okay. So, our topic is recognizing manipulated images using deep learning in Flask. So first of all, let's start with the introduction. Uh, and in introduction, I'll first like to explain the deepfakes. What are deepfakes? So deepfakes are the AI generated manipulated images that seems to be original but are not the original ones. So in our research paper, we are looking for the technologies that will be that technologies which will be helpful in finding if the given video or given image is the deep fake one or the original one. So this is the abstract, and abstract mentions all those things about the deepfakes. So let's go to the deepfakes introduction. Okay, so deepfakes were basically popularized in 2017 when Reddit user explicitly mentioned it, and similarly in 2018 when Obama deepfake was done by the Jordan Peele. Deepfake is classified in three types, like it is done in three ways. First one is a face swapping, second is a lip syncing, and third one is a voice replication. So these are some methods of creating the deepfakes. So for the technologies, talking about the technologies for the deepfakes, the technologies that are used for the deepfakes are generative adversarial networks, deep swap, soul chain, talking faces, etc. All these things are the used for deepfakes. So basically, a long time ago, like if we talk 10 years back, so 10 years back, the deepfakes were made and it were easy to recognize because technology was not so advanced at that time. But recently, the technology has become so much advanced in machine learning and artificial intelligence that it is quite difficult to recognize if the given image, if the given video is the original one or it is the duplicate one. So there is a need for the very advanced technology that could clearly identify and mark difference between the original one and the real one. So this detecting technology should be as much as advanced the creating technology is. So we are researching this thing in our research paper, this whole thing. So let's talk about technologies. So first, let's talk about the technologies that are used for creating the deepfakes. So first one is support vector machine. So what support vector machine basically does is the support vector machine is basically used for the thing that is used to classify into binary things like it's spam or not spam, it's fake or it's real one. So what support vector machine actually does is it makes the two classes and differentiate between the two classes. So this two classes is like this first one class, this is second one class, and it draws the hyperlink between the two classes by taking out the averages from the closest one. So the best quality about support vector machine is that it has got that ability to ignore the outliers present in the both side. For example, if class A element is present in class B, so it has that ability to ignore that element and classify it properly. So let's move to the second technology. Second and the most important technology in terms of deepfakes is generative adversarial networks. So what generative adversarial networks is basically in art in this deepfake is used like it's first of all, generative adversarial networks consist of two components. First one is a generator and second one is a discriminator. So what generator basically does is generator takes the input, a random noise as the input, and creates one particular fake. Let's talk about first images. So it takes a random input and creates a fake image out of this random noise. So what happens later one is discriminator that compares this generator output, that is the fake image created by generator, with the training data. So now basically what discriminator will do, it will classify it as a fake because it is generated from a random noise. Okay, so now this discriminator is classifies it as the fake. So now this discriminator data is passed on to generator again. So generator will improvise it and make it similar to the training data. So again discriminator will see, it will find some difference, classify it as a fake, and this process will go on, go on, go on. There will be one time when generator will improve very very finely, and generator will make such an image which is very similar to the input data, and there will be hardly any difference. So this is the work of generator, that is to improve, and this data is trained to the model to identify if it is a real one or it is a fake one. And in this case what it does, generator task is to make it very very accurate, to make the fake image very accurate as similar to the training data. So generator makes the image. Again now what happens, discriminator sees this image. Now discriminator identifies image as a real, though this image is fake one, still it identifies it as the real one. So this time it is the discriminator's loss. So now it's discriminator loss, so it's time for the discriminator to improve upon it. So now discriminator by getting input as the previous generator's data as well as the training data, improves upon it and improves its classifying technology. Similarly, when generator creates image and discriminator classifies it as a fake, then it is a generator loss. So these are the two technologies that are used in our system. So ma'am, methodology and architecture will be presented by my co-presenter, that is Shantanu Totewal. So Shantanu, please present.
Okay. Hello, ma'am. Methodology involves three steps. First is pre-processing, second one is feature extraction, and last one is classification. In pre-processing, the image, the deepfake image is given to the pre-processing tools to resize its size, means to resize it in 256 cross 256 traditional size, so that it can be helpful for feature extraction in the CNN models. In feature extraction, we are using feature extraction to extract the different features from the images. So we are using the CNN model, ResNet model, which has 101 layers. A pre-trained deep learning model with 101 layers. It employs residual learning with shortcut connection to enable efficient training. Why we are using ResNet is ResNet provides us a residual block features, which is skip connection features, which is really helpful to analyze deep features and comes to the deep neural network. The model learns feature hierarchy, edges, and texture in early layers and abstract pattern in deeper layers. Residual block apply convolutionally, batch normalization, ReLU activation, followed by pooling to reduce dimension. Pooling is used on feature vector to take an average among, suppose matrix like 2 cross 2, which reduces the uh, time and computation of the image. Okay, So this is our proposed architecture. Our proposed architecture has two phases, inference phase and training phase. In training phase, we are taking a big data set, a labeled data set of real and fake images. We are pre-processing it and training it on the ResNet model. So ResNet model, what ResNet model will do, it will extract the features through each and every layer. We are having 101 layer in the ResNet. So it will be impactful for every single feature for the deepfake image. So it will create the feature vector according to that, which are the numerical value with the label 0 or 1 means real or fake. And we are creating a classifier. Here, what we are doing new is we are not using the traditional fully connected layer or softmax function, which is primarily used in the conventional CNN models. We are using a SVM classifier because SVM classifier
Sorry
provides
to
us the
interrupt you, but you have 1 minute to conclude the presentation.
okay. SVM classifiers are used for hyperplane, means they can classify data of multiple dimensions, means it is impactfully it reduces the misclassification risk. Okay. And we are testing it with confusion matrix. We are testing with confusion matrix because the we can tolerate if real images detected as fake, but we cannot tolerate that fake images represented by real, because false negative is more important. That's why we have to test it with confusion matrix. And at last, the in inference phase, the image will be uploaded by user. It will be pre-processed, and feature extraction is done on these images. Again, the feature fusion is done because we are using two models, combined models, ResNet and VGG. The VGG models takes the input, takes the features which are lower features, means simple patterns, and ResNet are deeper. So using both of the models combinedly will enhance the system. So after that, we are making a pattern encoding and providing the actual result. So that was our architecture one. And now we are performing this by using the Flask implementation. In Flask implementation, we are providing the UI like Flask template engine, and also the backend queries like REST APIs and all. So, and also we are using the PyTorch framework for using this for training the models like ResNet and VGG models. So that was our architecture and our proposed system. Thank you.
Thank you so much for your presentation. Sir, do you have any questions?
I have a question regarding the presentation of research paper. My question is that on which data it was tested in your research work?
Means we are already training this data, our model on the face forensic data. We are planning to do now. We are using a custom data set, labeled data set of real and fake images, and we are just testing on that one.
What kind of images? Is it related to
Manipulated
any...
images, means created by AI, fake images, and the real real image.
Yeah, you mean normal I mean generic images, or like it's a facial image, or it's a medical image, or satellite image? Is there any particular domain related to it?
Real images, but manipulated by using AI tools. This kind of images.
Yeah, but what kind of image? Is it just a scenic view
faces.
or in? Okay.
Face images means
Okay.
because it is a reputation risk, right? So we are aiming that.
Yeah. Okay. Thank you.
Thank you so much for your presentation. So we'll be moving on to the next presentation now. Next, yeah. Can you please stop sharing your screen? So next we have Pundru to present the paper title, An Attention-Based Deep Learning Framework for Gold Price Prediction Using Time Series Data.
Yeah.
Are you there?
Yeah.
Yeah, you may please share your screen and begin the presentation.
Yeah. Can you confirm? My screen is visible?
Wait a second. Yes,
Visible
your
my
screen is visible. You may please start now.
Yeah. So very good afternoon to all. My name is P. Chandrasekhar Reddy. My topic is an attention-based deep learning framework for goal price prediction using time series data. So these are contents of my paper. Coming to here, as we know that one, so time series data analysis is a very difficult task, and in that one, the gold price prediction is the same as the stock prediction. It's a very complicated one, and so every day we have to be lot of businesses going on the gold prices. So it is a very challenging, and as of now, we have methods are already there, but those methods are not giving accuracy results. So to get the accuracy results and timely prediction of the gold prices, we used the machine learning with the deep learning models for accurate gold prediction. So gold prices are non-linear as we know, and uh, unexpected and volatile and unregular. So this is the major challenge while we are working on the gold price prediction. So we collected the data from the Cargill, some last 10 years gold prices daily wise, and we have seen the monthly wise also, and we made into the yearly wise how much predict. These are all combinations we are made and uh, in calculate this model. As we know that the classical statistics and machine learning approaches forecast is the not done much accuracy. So for that we introduced into the CNN models, and RNN offers the excellent and better accuracy when compared to those things. So here the model is the TCN and attention based mechanism we are using for this one is a hybrid model to get the this one. And this model extract the temporal properties from the sequential data. As we know that the gold price is a time series data and there is a sequential data. So that is the very difficult as per the general models. So we adapted weight distribution to information features, and this mechanism is introduced. Finally, the dense layers and uh, convolution layers are used to be CNN, and this approach predict the gold price time series data by using accuracy. And this model is assessed by the various metrics called as the MAC, the mean absolute error, and RMAC, and least favorable case, and 39% in the most favorable case. We got the results. Uh, as I told you, we providing a new model that optimizes the global attention for identification of the gold price. And I want to say you the main contribution. Yeah, these are the main contributions of my research. As I told you, the deep learning optimized design is utilized for the gold price prediction. And this attention module addresses the exponential and computational things about this one. And here, what I told, the CNN is improves the model concept relationship capturing this approach. And this improves the feature detection and computing efficiency. This is literature. I want to show you. We have done different types of literatures, and we identified. And here, just I kept for your reference purpose, and we have done many references. And what we identified is the limitations as not accurately and night timely predicting the gold price. This one to overcome that issue, we propose the hybrid model. This is the basically the layers how the CNN and TCN is going to be work here. This is the misalignment and the subsequent correction of the characteristics and their actual values allowed for the long-term prediction. And TCN was used for the first stage of data pre-processing to guarantee the correct model extraction of consortial leakages. And while TCN outperformed these all existing RN models in terms of total prediction accuracy, and it struggled to detect the critical nodes of trend changes in the long-term anticipation and produce the more volatile predictions output. These are come to results here. Basically, I want to show the yeah. This is the results graph, and this is the performance analysis of the proposed model. And in terms of RMAC and MAC and MAPE and R square. So these are the very good, better results we got when compared to the existing models, the in the time series data. And I will conclude that. The effectively exact temporal data in study proposes the TCQ attention model, which combines the CNN with the help of the self-attention models in order to extract the context time features quickly without compromising the accuracy. And these proposed layers can be used for result connections to reduce the error rate. In addition, a new QE attention method is used to improve the information extraction process. And finally, this area of study will be the finding sweet spot between the model complexity and testing time. And it will be the continuous to exhibit the good performance in the long-term predictions contact with the other models. This is my side. Thank you.
Thank you so much for your presentation. Sir, do you have any questions?
Yeah, no questions from my side.
Okay, I guess no questions then. So we'll be ending the session now. I sincerely want to thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of you. We, on the behalf of the whole team, thank you for your support during this fourth version and all the previous three versions of the conference. We will be happy to have you in the fifth version in 2026 as well. All the presenters would be getting their digital certificates within 2 working days, and the publication will be live within 7 to 8 months. So kindly cooperate with the team of ISBM 2025. Before ending this session, I would also like to take a moment to thank our session chair for chairing this session, Professor Randy. Thank you so much, sir, for chairing this session. I would also like to take a moment to thank Professor Sayan for chairing this session. Thank you so much, sir. Would you like to
Thank
share?
you very much.
Yeah. Would you like to share any closing remarks with us?
We would like to congratulate all the presenters and looking forward to see you again in ISBM 2026 and looking forward for your beautiful and handsome, should I say, good researches. Congratulations, everyone.
Thank you so much, sir. So, do you want to add on?
Yeah, congratulations to all the presenters and all the authors, and thank you to GR Foundation, Amit sir, Richa ma'am, and everyone involved. Thank you, Angshika, and thank you, Randy, Dr. Randy. It was nice to have all of you in this informative session. Congratulations and have a nice day. See you in the next year.
Thank you so much, everyone. I would request everyone to kindly turn on their cameras for a quick snapshot before we end the session. Thank you so much, everyone. Thank you for the session. Thank you for your valuable presence.